Okay, so assignment number 17, basic exponential functions. Let's start with plugging into exponential formulas. Okay, so I'm just gonna screenshot that. Maybe I didn't need to screenshot this. I feel like I could have just typed in the calculator, but it's okay. Let's read this situation. It says, a culture of bacteria has an initial population of 22,000 bacteria and doubles every 5 hours. Using the formula P of T is equal to P0 times 2 to the power of T over D, where PT is the population after T hours, P0 is the initial population, T is the time in hours, and D is the doubling time. What is the population of bacteria in the culture after 17 hours to the nearest whole number? Okay, so we really just need to literally plug it into this equation. So what is the population of bacteria? We need to find out P of T is equal to, so P sub 0 is the initial population. So they told us our initial population was 22,000. So that's this part. And then we have to write the times 2 to the power of T over D. So what is T? 17 hours is our T. And then what is our doubling time? Doubles every 5 hours. Okay, so I literally just plugged it in. This is our doubling time, so it's the D. Doubles every 5 hours, that's our doubling time. And then the 17 hours is our T because that's how long we're going to wait for the bacteria to double. And then our starting time is 22,000. Literally all we have to do is type this into a calculator. So I will type this into a calculator, but before I do, are there any questions? So let's type that in. I'm just gonna use Delta Maths calculator. Okay, so 22,000 times 2 to the power of 17 over 5. Literally just typing it in. And then it says 232,233.39. And remember, we are rounding to the nearest whole number because you cannot have 0.3 of a bacteria. So you want it to the nearest whole bacteria. So 232,233. Did I type that right? There's so many 2's and 3's, my gosh. Okay, 232,233. Okay, I think that's correct. We rounded it to the nearest whole number, and I'm going to submit. Cool. Let's do another example. Same thing, but we have different starting numbers, different doubling time, and different number of hours. Actually, it's the same number of hours, but let's just type it in over here since we already have the calculator out. So our initial population is 72,000. So I'm going to go over to my thing that I'm typing into the calculator. Why is it not letting me? Okay, you know what? 72,000. Then times 2 to the power of T over D. So what is the amount of time? Try to highlight it. Okay, it's not letting me highlight. But what is the population of bacteria in the culture after 17 hours, which is the last sentence? Even though it's not letting me highlight it, I will type that in. 17 over, and it has to be T over D. So what is our doubling time? In the first sentence, it says the culture of bacteria has an initial population of 72,000 bacteria and doubles every 10 hours. So our doubling time is 10 hours. So I will have 17 over 10. Sorry, I was really just trying to highlight the words, but it wouldn't let me highlight it. Okay, this thing that's highlighted, that is our T. And that thing that's highlighted, that is our D. There you go. I found out how to highlight. So I put them into the formula and we got 233,928.6902. Remember, we are rounding it to the nearest whole number, so 233,929. So it's not 928.6, it's 929 because 6 is a big number, so we're going to round it up. Any questions on this one? Okay, let's submit. And let's see, is there another type of, yeah, okay. So I just clicked show example because there is another type of problem, but it wasn't giving it to us. I guess, let me find one. C solution. I guess they changed the button, huh? Now it's a C solution. Okay, cool. So I found our second type of formula, or second type of example. So I'm going to screenshot this. It says a person places $8,620 in an investment account earning an annual rate of 6.1% compounded continuously. Using the formula V is equal to P times E to the power of RT, where V is the value of the account in T years, P is the principal initially invested, E is the base of a natural logarithm, and R is the rate of interest. Determine the amount of money to the nearest cent in the account after 14 years. Okay, so we're just going to use this formula just like we used the other formula they gave us. We're going to find the V. So what is P? P is our principal initially invested. So that would be 8,620. And then we have the letter E. The letter E, it represents a special number in math, just like pi is a special number in math, which is like 3.14-ish. E is a special number in math that's like 2.8 something. Okay, so it's just another special number in math. So we're going to be able to type E into the calculator, and the calculator will know what we mean. So 8,620 E, and then we have to the power of R being 6.1%. Okay, so we need to convert this into a decimal. So I'm going to take the 6.1, which is currently as a percent, and you want to move that decimal spot 1, 2 to the left. So that becomes 0.061. So notice that the decimal spot has moved 2 spots to the left, and now this is the decimal form of 6.1%. Okay, so then I'm going to put that there as our R. And then T is, where does it say? Oh, in T years. So T is the amount of years that we want to plug in. So that would be 14 years. Okay, so this is what we're going to type in to our formula. Before I type it in, are there any questions? And I'll pause the video so you have a chance to ask. All right, let's type this in to the calculator. Clear that one. We have 8620. That's P, E. You can just type it on your keyboard with the letter E. You don't have to use this keyboard on that calculator. Okay, to the power of R times T. Okay, and it says $20,248.588. We are rounding it to the nearest cent because money can be split into cents. And so we want 2 decimal places. So it's 0.588. That second 8 is a big number, so we're going to round that first 8 to a 9. So 20248.59. Did I type that right? Yes. Okay. So $20,248.59. Are there any questions? Okay, and then let's do one more, hopefully with this type of example. Cool, they gave it, I don't know why, they're actually giving us the good examples this time. So let's just go ahead and change the numbers in our formula on the calculator, since you've already seen me write it out. I don't think you need to see me write it again, since it's just going to be typed the exact same way. So let's get rid of that. Oh no. Okay, let me just type it from the start. 37,700 right over here. This is your starting amount. This is going to be the P in the PERT. So I typed in 37,700 already. Then I'm going to go type E. And I'm going to raise it to the power of R times T. So remember, R represents the 5 over here, the percentage. So 5 as a decimal, you're going to take that decimal that is already there. Actually, I need to screenshot this one. I forgot, I do need it right here. So right now it's 5%, right? there's a decimal right over here. You're going to move it 1, 2 to the left. So this becomes 0.05. So this is our R. And then finally for our T, I'm just going to put 16 years because that's how many years they want us to wait. So in the calculator, I'm just going to type a 0.05 times 16. So let me go ahead and actually type that in now. Oh, okay, 0.05 times 16. Cool, and it says $83,902.893. So remember that 3 is a very small number at the end, so I'm just going to keep it as a 0.89. So $902.89. Any questions? All right, so I think that's enough examples for plugging into exponential formulas. Let's go to the next video.